Okay, welcome back to Mr. Hassan's Maths channel. I am now answering question number 6 from the Mechanics M1 January 2021 International A-Level Edexcel paper. It says two girls, Agatha and Briony, are roller skating inside a large empty building. The girls are modeled as particles. At time t equals 0, Agatha is at the point with the position vector 11i plus 11j meters. And Briony is at the point with position vector 7i plus 16j meters. The position vectors are given relative to the door O, the door is origin, and I and j are horizontal perpendicular unit vectors. Okay, so alright, so they are perpendicular to each other and they are horizontal, meaning when they say they're horizontal, it means it's like we're kind of on a flat plane, horizontal plane. One of them is I going this way and one of them is j going that way, perpendicular to each other. Okay, so that's what it means when it says horizontal, because it's like, you know, the girls are skating on a horizontal surface. That's what it means by that. Okay. Agatha skates with a constant velocity of 3i minus j meters per second. Briony skates with a constant velocity of 4i minus 2j meters per second. Find the position vector of Agatha at time t seconds. Okay, now the position vector of an object moving at a given velocity for a given time, okay, is given by this formula r equals r0 plus vt, where r is its position vector at any point that we want to find t, for any time we want to find t. R0 is its position when time equals 0. And v is its velocity vector, the vector that describes what its velocity is. And t is the time, in this case, it's going to be in seconds. So in our case, for Agatha, what we have is, we have R0, because at time equals 0, she is at the point with the vector 11i plus 11j. I'm going to write that as a column vector, because I like to do my working using column vectors. Okay, I know what R0 is. I know what the vector v is. Agatha skates with a constant velocity of 3i minus j. So I'm going to write this as 3 minus 1. Okay, that's the velocity vector. And that's all I need, because the position vector at any point, any time t, is equal to R0, which is 11 plus the velocity times the time. So it's the time times the velocity vector, 3 minus 1. And that's it basically. Now, because I gave everything in terms of I and j, it's best for us to write, the position vector of Agatha. I'll put it as RA is equal to 11i plus 11j plus t times, and you're going to have 11 t times, and you're going to have 3i minus j, 3i minus j. Okay, so that is the position vector of Agatha after t seconds. Okay, you can write it as a column vector. I like to use this for my calculations. You can write it as a component in terms of I and j. Then it says at t equals 6 seconds, Agatha passes through the point P. Show that Briony also passes through P, and find the value of t when this occurs. Okay, so now, first of all, we got to find Briony's position vector. So I need to find what Briony's position vector is. I'll call it RB. I know that at time t equals 0, Briony is at the point 7i plus 16j. Okay, so I know that R0 is 7i plus 16j. Okay, that was right, 716. Yes. And I know the velocity of Briony is 4i minus 2j. 4i minus 2j. So the velocity is 4i minus 2j. So for Briony, her position vector is given by 716 plus t times 4 minus 2. And it's saying at time equals 6 seconds, okay, Agatha passes through the point P. So when t equals 6, the position vector of Agatha is going to be given by 11. I'm going to use this thing. 11 plus 6 times 3 minus 1. 6 times 3 minus 1. That's going to be where Agatha is. 6 times 3 minus 1. Sorry about this. What am I doing? 6 seconds. T is equal to 6. And you got 3 minus 1. Sorry about that. It's a bit late now. Okay, so that is going to tell us where Agatha is after 6 seconds. So that's 11 plus 18. That's going to be 29. And that's 11 minus 6, which is going to be 5. So that's the position vector at time equals 6. And we know that she passes through this point at a certain time. Okay, so we know that, okay, when RB is equal to 29.5, okay, then she's going to be passing through that point. So let's see what the value of T is for which that happens. So let's equate RB to 29.5. So we have 716. This is when Briony is going to pass through that point, plus T times 4 minus 2. If she passes through that point, okay, you're going to end up with a value of T which is consistent with both top and the bottom components, the I and the J components. So let's compare the I components. We've got 7 plus 4 times T equals 29. And let's compare the J components. We've got 16 minus 2T equals 5. If they give us the same value of T, then that will be the time at which Briony passes through this point P. Okay, so you're going to have 4T equals 29 minus 7, which is 22. So T is 22 over 4, which is 11 over 2. So T is 5.5 seconds. Let's see if we get the same answer for this. You're going to have 16 minus 5 equals 2 times T. That's 11 equals 2T. So yes, T equals 5.5 seconds. So we have shown here that Briony passes through P, at the same point P, but at time 5.5 seconds. Okay, so as both T values are the same, okay, we can say, when it says show that, you should always mention a little proof. We can say that Briony, however you spell her name, Briony, passes through P at time equals 5.5 seconds. Okay, so we have proved part B. Okay, so we proved that she passes through P because we equated her position vector with P and found that the T was both the same for both of them. Therefore, she passes through that point at that time. Okay, so we've done that. Find the value of T where this occurs. That's the answer to part B. Now for part C, it says at time T seconds, Agatha is at the point A and Briony is at the point B. Show that the vector from A to B is given by this expression T minus 4i plus 5 minus Tj. Now, here we have an expression for the position vector of A and the position vector of B. This is the position vector of Agatha. This describes the position vector of Briony at time T. So we got to show that the vector from A to B is given by this vector here. So how to get from Agatha to Briony at any particular time T. So what we're going to do here is we're going to think about how to deal with this. So this RA actually means, the vector RA means from O to A, the position vector of A. And RB means the position vector of B from O to B. So just imagine this is O, and say this is A, and this is B. What we have here, we have the vector from O to A, and we have the vector from O to B. Okay, we know how to get from O to A and O to B anytime T, these two vectors here. That's RA and that's RB. We have to find, in this question, the vector that takes us from A to B, which is this vector here, from A to B, that way, that direction. Okay, now if we look at this, we can see if I want to go from A to B, it's the same as going from A to O, and then from O to B. A to O, and then O to B. And A to O is the opposite direction of the vector A, so it's minus RA and plus RB. So A to B is going to be basically the vector of Briony minus the vector of Agatha. So what I'm going to do first is I'm going to express this as like a single vector, I and j components. So you have 11 plus 3t, and this is going to be 11 minus t. And for this vector, it's going to be 7 plus 4t, 4 times t, and 16 minus 2 times t. And I've got to do, I want to find the vector from A to B. So the vector from A to B is, as we've discussed, RB minus RA, which is going to be this vector minus that vector. So you're going to have 7 plus 4 times t and 16 minus 2 times t minus 11 plus 3 times t, 11 minus t, which gives us the vector 7 minus 11 is minus 4, minus 4t minus 3t is plus 1t, and you've got 16 minus 11 is 5, and minus 2t minus t is minus 2t plus t, which is minus 1t. And if I write that in terms of I and j, you can see it's going to give me exactly this. I'm going to have t minus 4 as the I component, and I'm going to have plus 5 minus t as my j component, and that is in meters. So there we have shown that the position vector of A to B is given by this vector here. Okay, so that's done. And then it says find the distance between the two girls when they are closest together. All right, so this vector here, which we found A to B, tells us the vector, how to get from one girl to the other, how to get from, what's the name, Agatha to Briony. Okay, so this is a vector that describes the displacement between these two girls, basically. Okay, which is, I'll write it in this form, minus 4, I can write it like this better, t minus 4 over 5 minus t. So whatever value of t that I put in here will tell me the vector to get from Agatha to Briony at any particular time, t. So if I put t equals 4 here, the position vector of how to get from A to B will be 0 and 1, for example. If I put t equals 10 here, 6 and minus 5. So whatever value of t I put in here will tell you how to get from A to B. Now we want to find the distance between the two girls when they are closest together. So the distance, remember, is the magnitude of the displacement. So if I take the magnitude of this vector, I'm going to have the square root of t minus 4 squared plus 5 minus t squared. All right? So this is the magnitude. This is like the distance between the 2 points at the time t. I need to find a minimum value for this expression. Okay, so the distance is equal to the square root of, oops, what happened there? The square root of t minus 4 squared plus 5 minus t squared. Now, that's, if I want to find the minimum value of this, there's a few things I can do. Okay, let me write it a bit neater. The square root of, you've got t minus 4 squared plus 5 minus t squared. Now, one way to find the minimum of an expression like this is to differentiate. You can find the differential of d with respect to t. Okay, you can do that. But when it's in this form, that's kind of like a bit of hassle because you've got a square root here. So if I think about it, if I square both sides, so I've got d squared, and then I've got t minus 4 squared plus 5 minus t squared, and I differentiate this, so let me expand it first. So I've got d squared equals, that's t squared minus 8t plus 16 plus 25 minus 10t plus t squared. So I'm going to end up with d squared equals 2t squared minus 18t plus You got 16 plus 25, that's going to be 41. 25 plus 16, that's 35 plus 6, 41, yeah. So you got 2t squared minus 18t. Yep, okay, that's right. Okay, so now we have this expression for the square of the distance between these 2 points. So, of course, if the square of the distance between the 2 points is the smallest it can be, that will be the same value of t at a particular time. Then that for that same time, that's when the distance between them is also going to be the smallest possible. Okay, because if you're talking about the square of the distance at this time, it's going to be the smallest as possible. At that same time, the actual distance will also be as small as possible. So if I find the differential of d squared with respect to t, okay, so this is one way of doing it. Find the minimum of this expression, differentiate it and make it equal to 0. How you find a minimum from what we learned in P2 is you find the gradient function, you equate the gradient to 0, and you find the value of t, and that could be either maximum or a minimum. In this case, it's going to be a minimum because this is a quadratic. Okay, it's a quadratic that opens upwards. So this is going to give you 4t minus 18. So when the differential is equal to 0, okay, you're going to have 4t minus 18 is equal to 0. So t is equal to 18 over 4. So t is going to be, that's going to be 18 over 4, which is 9 over 2, which is 4.5 seconds. After 4.5 seconds, there'll be the closest distance. So we've got to find that distance. So we can just replace 4.5 in this equation here. So we can say d is equal to, you're going to have the square root of, we'll find the actual distance now. So you're going to have 4.5 minus 4 squared plus 5 minus 4.5 squared. Let's put it back into here. So the distance is going to be, that's going to be a half squared. Okay, so that's 0.5 squared, so 0.25 plus, again, a half squared, 0.25. So you're going to have 0.5 squared, and you're going to have another 0.5 squared, yes. So that's going to be the square root of a half. Okay, and the square root of a half gives what? So you have the square root of 0.5, which gives us root 2 over 2. Okay, which as a decimal is going to be 0.707. 0.707 meters. So that is the minimum distance between them, okay, because we basically found an expression for the distance between them, which is the magnitude of the vector, which describes the displacement. The magnitude of that vector is the distance between them. And we have to differentiate this and make it equal to 0 to find the minimum value of d. Now that's a bit complicated to do because of the way it looks like this. It's not impossible. We have to use what's called the chain rule, which comes later. M1 is kind of for students who have done, you can't do anything more than what's in P2. It should not contain anything which is more than P2, because some students take it after P1 and P2. In AS, some people take it after A2, so it should not contain anything which is more than P2 material. So to differentiate this using the chain rule would be outside of the scope of that. So that's why, this is another way of doing it. In fact, this actually makes life a bit easier than the chain rule anyway, because of the square root sign. So basically, you expand, you square both sides. You say, okay, I know the time at which the distance is a minimum will be the same time at which the square of the distance will also be a minimum. Okay, so just taking the distance and squaring it, the time will be the same. Okay, so therefore, you'd find the differential of the expression. So we squared both sides, we simplified it, we differentiated that expression, we made it equal to 0 to get the minimum. We know it's a minimum because it's 2t squared. It's got a positive square term, so it's a smiley face, you could say. And you find the value of t, but the question says find the value of the distance, so we substitute that value of t, for which the minimum distance, into the distance formula that we found originally here, and that gives you the distance when they are that much apart. Now we could also have done the same question from this stage here. Once I've got d squared equals, so I'm going to show another way of doing this. This is one way using differentiation. This is using differentiation, but because we have a quadratic, we can use also completing the square. So I'll just show you how that works. Completing the square would also work because it's a quadratic formula here. You've got d squared equals 2t squared minus 18t plus 41. So if I complete the square for this, all right, I'll get the following. I'll have d squared equals, I'll take from these two terms the 2 out. So I've got t squared minus 9t plus 41. Okay, so then that's going to be 2 times, then I have t minus a half of the coefficient, which is 9 over 2, minus the square of this, which is 81 over 4. And I got plus 41. So that's d squared equals, this is 2 times the bracket t minus, this should be squared by the way, t minus 9 over 2 squared, okay, that's a squared bracket, minus, and I got 2 times minus 81 over 4, which is minus 81 over 2. I've got plus, I have to add this to this, so I'm going to make this 82 over 2, because now they have to be added together. And that gives me, I'll just continue over here. Okay, so I'll continue over here. Right, I've got, that gives me d squared equals, I've got 2 times t minus 9 over 2 squared. Now that's going to give me plus a half, because minus 81 plus 82 is 1, so plus a half. So we can see that the minimum point is going to be at 4.5 and a half. Okay, so when t equals 4.5, this is d squared. So we know that d squared is equal to a half when t equals 4.5. Therefore, d is going to be the square root of a half, which is exactly what we got there, which gives you 0.707 meters. So that's an alternative way of answering the same question using completing the square. We take the expression for the square of the distance between the 2 points. We find that the square of the distance between the 2 points is a minimum of a half, right? So therefore, the actual minimum distance between the 2 points is the square root of that. Okay, d squared is equal to half, so d is going to be the square root of a half. And there we have answered this question, part D. All right, so there's the answer for that. Thank you for watching this video. I hope you understood it. Other questions you might want to watch from the January 2021 Mechanics M1 paper can be found on the playlist that will appear in this area over here. Below it will be a playlist about vectors in M1. You can subscribe to my channel by clicking on this link, and at the top of the page here you will find card that's been appearing from the beginning of the video from time to time, taking you to a different M1 paper you might want to watch. Thank you and see you soon.